ArcelorMittal Ghent is a fully integrated steel plant situated in the port of Ghent, Belgium. It manufactures flat carbon steel products with a high added value. Coil manipulations play a major role within the supply chain process of ArcelorMittal. It has several cranes for coil manipulation. Each coil weighs up to 30 tons, can have razor-sharp edges and a temperature of about 500 degrees Celsius. It's clear that moving coils, each worth the price of a medium-sized car, is a delicate and sometimes stressful job. Equally clear is the potential risk of injuries, even fatal ones. But there's also the economic risk of failing to supply on time the different production lines. Therefore, a team of cold roll mill engineers was asked to investigate the possibility of having these coil cranes operate fully automatically. Our challenge was to transform an existing 1970 manually operated crane into a state-of-the-art fully automatic one. Next to the safety aspect, our objective was to have a return on investment of less than 2 years. As for the automation concept, we were looking for a robust, reliable and future-proof open technology. This is why we took the Profinet technology into consideration. One of the first things the crane should be able to do is locate the exact positions of each coil and the train wagons. In our MES database, we store the position of each coil. But you never know the precise position of a coil on the saddle. It can be exactly in the middle or slightly to either of the sides. Determining the position is even harder when working with train wagons. You can't predict exactly where a wagon will stop, so we include some margin in advance. A fully automated system has to cope with all these variables, with no margin for errors. And in this case, such a system practically had to be built from scratch. If you take the operator out of the crane, you have to replace him with an intelligent device that can take over his tasks. On the one hand, the engineers use an MMI server to be linked to the company's local area network. On the other, a single PLC that handles control and safety tasks and can be linked to Profinet. The combination of MMI server and PLC forms the brain of this structure. The crane weighs 180 tons and reaches speeds up to 1.6 meters per second. Whenever there's a safety hazard, the crane has to stop immediately. So we opted for the Simatic S7-416 failsafe PLC because it combines the function of a regular PLC with additional safety functionality, integrated in the same device. Apart from the safety aspect, the crane has to know which tasks to perform. The MES database determines and prioritizes all coil movements. In the past, a wireless link towards the operator's cabin transmitted these data. But this WLAN system was not able to achieve the necessary network availability. So a new and more reliable WLAN connection was established between the MES system and the moving crane using SIEMENS W, an industrial WLAN product line of Siemens that complements Profinet. The crane has one fixed link with the ground, and that's the power cable. It would have been possible to integrate a communication line within this cable, but that would have required changing the entire cable and cable reel. Using SIEMENS W saved us about 35,000 euros in material and installation costs. Another interesting feature the engineers designed to allow independent crane operation is the laser. It scans the environment and sends this information via an Ethernet connection to a Siemens industrial PC in the crane, where a 3D image of the surroundings is created. It's a crucial safety instrument, since it helps determine whether there are any obstacles in the operation range of the crane. It also pinpoints the exact position of the coils on the saddle or on the train. Even the shape and condition of the coil is carefully monitored. If the coil seal's broken, there may be a flap hanging loose underneath the coil. There's a serious risk that this flap will damage other coils or, in the worst case, get stuck and damage the crane. With all this information, the tongs can move in to perform their task. These tongs are equipped with different sensors. Another SIEMENS S7 PLC, located on the tongs, sends all the information from the sensors to the S7 416 failsafe PLC in the crane. With all this movement going on, unrestricted access to the stockyard is not an option. So a fence has been installed surrounding the entire stockyard. The fence has a total of 14 entrances, equipped with safety locks and Siemens ET200S remote I/O modules. These modules are linked to a SIEMENS S7 failsafe PLC through a Profinet network. Whenever one of these doors needs to be opened during crane activity, this safety PLC sends a signal via Scalen's wireless technology to the SIEMENS S7 416 failsafe PLC on the crane. All crane activities are stopped immediately. All this combined Profinet-based technology results in a crane that can perform its tasks without human intervention, thus reducing costs and improving safety conditions for man and machine. The cold roll mill project team of Arcelor Ghent managed to finish the project successfully at minimal cost. With an expected return on investment of less than 2 years, other cranes will follow in Arcelor Ghent. Other Arcelor sites are also showing a considerable interest in this project. A successful combination of smart engineering and the use of innovative technology.